All right, in this case we have, to begin the problem, a supply equation and a demand equation here. We're starting with the assumption that P equals Q represents supply, and our supply in the graph is right here, and that P equals 100 minus 3Q is our demand. Right? That's given information in this case. What we typically want to do when given such equations is find the equilibrium quantity, okay, and that's going to be here, and the equilibrium price, and then we typically want to identify the area of consumer surplus and the area of producer surplus. So that's what we'll try to do in algebra this time. So first thing we want to do is graph P equals Q. Remember from your old algebra days the formula y equals mx plus b. I'm pretty sure you saw that at one point or another. B refers to the y-intercept, that is the value of the y variable when x is 0. M refers to the slope. So in the supply case, P is our y, our slope is 1, Q is our x, and we have a 0 intercept. Okay? In the case of demand, P equals a -3 slope, so minus 3Q plus 100. There's our y equals mx plus b format. Okay? It's typical that we'll start by converting things into that format so that we can play around with the equations then. Might need to do a little algebra review or make up some equations and practice graphing them in order to get comfortable with this if you haven't had much experience with it. Alright, so what do we want to do? We want to recognize that if we're looking for the equilibrium, two things are true. Number one, the quantity at that equilibrium, given by both the demand and the supply curves, is equal to 25, and the price is equal to 25, okay? Or they are equal. You get the same price on the demand and supply curve at that point. You get the same quantity on the demand and supply curve at that point. So we can use that information to actually solve for the equilibrium quantity or the equilibrium price. Since I've already got price by itself in these two equations, I'm going to simply note that at equilibrium, the supply price is equal to the demand price, which means that the right-hand sides of these expressions are also equal. That is, Q equals 100 minus 3Q. Okay? So we're going to equate those two expressions and then solve for Q by getting Q all by itself in one side and then isolating it. So if we add 3Q to both sides of this expression right here, we end up with 4Q equals 25, and that means that Q equals 25. Sorry, 4Q equals 100, my bad, and therefore Q equals 25. Once we've gotten the Q equals 25, we can plug it into either the supply or the demand relationship, and we can then solve for the unknown price. I like to look for the easier equation to use. In this case, it's the supply, where it's P equal Q. So if Q equals 25, P equal 25, and we have our equilibrium price. Next thing we would want to do is look for the consumer surplus and the producer surplus. So graphically, what we're looking for is this area right here. Okay, it's above the price of 25 and below the demand, and it goes all the way out to the equilibrium quantity. So that triangle area is going to be the consumer surplus. And we're going to use the formula, the area of a triangle is a half times the base times the height. Okay, so we can treat one of these sides as the base, one as the height, multiply them together and multiply by a half. So 100 minus 25 is 75. So we can take 75 and we can multiply it by 25, and then we can multiply by a half, and that will give us our consumer surplus. Here we're going to take the 25, that's the base, times the 25, the height, so 25 times 25 times a half, and that will be our producer surplus. Alright, so when we do that, we have an expression for consumer surplus equals to a half times 100 minus 25 times 25. That's going to equal 937.5. We do the same for the producer surplus. We end up with 312.5. We add them all together, we get 1250. And remember, what we've created here is a dollar-denominated measure of consumer and producer well-being. Taken together, we call that total surplus. And this could be thought of as a measure of total societal well-being in the absence of any externalities. But what if an externality exists? Okay, specifically, what if for every unit of Q produced, an external cost of $20 is imposed on others? So some pollution is generated from the production of this good. Makes it more expensive for the nearby community to extract the pollutants from their water supply, or it gives them some health problems or whatever. Okay, and somehow economists have come up with the idea that that value is $20 per unit of production. We have a chapter subsequently in the course where we talk about how we would think about valuing externalities. So if this is the case, and if it's at the point of production, okay, for every unit of Q produced, not consumed but produced, then the marginal social cost is going to deviate from the supply. Supply is still P equals Q, but the marginal social cost is now higher. It's $20 plus Q. So we have an equation expression for the marginal social cost. All right? And we can graph that in our original diagram, right? If we want to find the optimal output, instead of equating P equals Q with 100 minus 3Q, we're now going to equate the marginal social cost with the demand, that is the marginal private value, which happens to also be the marginal social value because there is no externality at the point of consumption. So we equate 20 plus Q with 100 minus 3Q. We gather terms in Q, so I'm going to add 3Q to both sides, and I'm going to subtract 20 from both sides, and I end up with 4Q equals 80, or Q equals 20. Okay? So what this means is that the socially optimal level of production is different from where the market will take the level of production. The market's going to take us to 25 because there's no incentive for buyers or sellers to take into account this external cost that's being imposed on the nearby community. So if we want to compute the total surplus now, okay, the total surplus of the socially optimal quantity is actually going to be a half times 100 minus 40 times 20 plus a half times 40 minus 20 times 20. So our socially optimal level of output will have a total surplus of 800 associated with it. Now that there's an externality, we can also ask, what is the total surplus associated with the equilibrium quantity of 25? Back when there was no assumed externality, the total surplus was 1250, but now there is an externality, and so what the market equilibrium is going to do is overshoot with respect to the socially optimal level of quantity. So we have to take this 800 and we have to subtract off this triangle, which is a kind of deadweight loss, 1/2 times 25 minus 20 times 20. And so the total surplus associated with the market equilibrium quantity, that's what we think the market is actually going to produce, is 750, which is actually lower than the socially optimal total surplus, which is 800. So this exercise gives you some practice dealing with supply and demand equations, building in externalities, and comparing total surplus without externalities to total surplus with externalities.